We are now recording. Nicholas, I think it's yours to take it away.
Okay, and everybody can see my title slide?
Yep.
Okay.
We see it.
Okay.
Can I make a quick announcement?
Sure, go ahead.
Can I introduce you?
Sure.
Okay, so everyone, here we are on Juneteenth of 2024, celebration of a happy moment in our history. And we have the pleasure and the honor of one of our students, Nick Smythe, who is going to be presenting about eye tracking, which is kind of a new thing coming up and could be very interesting for many of you who are still considering your dissertations, in fact, and learning how something like this could be really useful in clinical practice, aside from research. So I will now let Nick take it over.
Thank you, Cynthia. Yeah, tonight I'm going to be talking about eye tracking and applied psychophysiology, neuroergonomics, and optimal performance. This presentation is just a basic overview, and I hope to see many of you at the RLE in Pasadena, to where we'll actually have hands-on experience with a tracking device that you'll be able to experiment with as well. So what I want to this evening, I'm just going to talk about, what is understanding what eye tracking is, and applications in three particular areas: neuroergonomics, which many of you know that's a passion of mine, and enhancing performance, and the future directions. And within this area, we'll also talk about specifically in applied psychophysiology as well. So first, we're going to talk about understanding eye tracking. And before I move forward, I just wanted to show, these are some of to the left, these are some different eye tracking devices. And we'll talk a little bit about those as we move forward. So first of all, eye tracking technology, there's a base definition, which is eye tracking monitors and records eye movement, including the point of gaze, the duration of fixations, and proving insights into cognitive processes and attention. Now, this includes fixation points, as it mentions, and also saccades, which we'll talk about that in just a little bit. But this is a basic definition for eye tracking. And the systems normally include infrared light sources, cameras, and it has an algorithm that capture eye movements to allow measurement of visual attention. One point I want to mention about that is that it does have some limitations, which we can talk about later, that a lot on the peripheral edge of the eye, it's hard to pick up. So the big advantage about this, it offers non-invasive real-time assessment of visual attention, of course, making it a valuable tool in human behavior and cognitive processes. So the principle of eye movements, as I mentioned about saccades, a saccade is a rapid shift. Now, I'm just going to give a simple, basic example of this. If you think about reading a book and you get to the end of a line in a book and you move your eyes from that one end to the beginning of the next line, that's a saccade. You're rapidly moving to another point. So if you can kind of think of a saccade as that it's a rapid movement from one point to another point. And this can be, saccades are very important in different avenues, in sports, in military flight operations, and even in marketing, looking at web pages and things of that nature, and even for gaming enthusiasts. And so, between fixations, the eye remains relatively still, and then it reflects on an object that comes to its attention. So visual attention is when the eye tracking data reveals patterns of visual attention indicating areas of interest and cognitive workload during tasks or stimuli presentation. So of course, your eye is going to go track to something that it picks up as interesting. And then we have cognitive insights, which is by analyzing eye movement patterns, we as researchers can gain insights into the cognitive process, decision making, and attentional control. So there's people who get fixated on different points and they stay at that point, which can be disastrous depending on what you're doing, or space out and then they move across. So we're able to track that night using this new technology. So eye tracking, as far as methodology, there's a calibration process that you have to go through, a data analysis process. So in the calibration process, you have to calibrate the device by assuring you're going to get accurate gaze tracking and participant focus. And this is during the setup phase, just like any device. We do a calibration and neurofeedback, biofeedback, QEEG, same thing. You're going to do some type of calibration to make sure the eyes are tracking the way they're supposed to on the particular device you're using. And then as far as the analysis, depending on how deep you want to go into analysis, the eye tracking software will pick up gaze data to identify fixation, duration, saccade amplitudes, and areas of interest. And when I say areas of interest, so you're using it for marketing on a website design, and maybe you're trying to get people to look at a particular area, you can be able to pick up if they're looking at that or they're looking at something else and then adjust. And so by providing quantitative measures of attention and cognitive processing, we can be able to see where the eye is going. And as far as applications to human behavior and cognitive performance, eye tracking is used in many fields, including psychology, marketing, human and computer interaction, applied psychophysiology, and optimal performance and neuroergonomics. Now, one thing I want to say about the optimal performance, I can talk a little bit about this later. There is a particular case that I'll talk about that's dealing with the Swiss hockey team using this technology. So I'll get to that in a few moments. Now, there are some limitations and considerations. There's environmental factors. You're looking at lighting, participant positioning, screen reflections, the accuracy of the technology you're using. So we got to take that into account. And there's also individual differences. Everybody's got different physiology of the eye and interpretation of what they see. So we got to take that into account. And then another limitation or consideration is that during eye tracking, we may not be able to tell, the eye tracker may not be able to tell what the individual is seeing or what they're looking at, but it may blur out. So that means that we have to take that into account as well. Now, some of the applications in neuroergonomics and psychophysiology is really interesting. This top left photo is from an aircraft cockpit. And as you can see, the lines and the dots on there, that's where an individual is looking at across the cockpit. And I just put that up there just to give you an idea of what the eye tracker can produce for you looking at it. Now, this other one is an individual looking at a application on a smartphone, and they're also through a eye tracking device that's like glasses. So that's one particular type of eye tracking device. And also they're recording other physiological data. So with that said, in cognitive workload assessment, we can look at task performance, human-machine interaction, and neuroergonomics. So in task performance, provides real-time assessment of cognitive workload during task to identify high mental effort and cognitive strain. Whereas in human-machine interaction, you'll look at the cognitive demands of interfaces of particular user-friendly and efficient systems. And then in neuroergonomics, it's used for human performance and also looking at optimizing workload, such as mental workload and cognitive workload. mental state monitoring, you can also use this for stress and fatigue, where eye tracking can detect signs of stress and fatigue through changes in visual attention and fixation patterns. Uh, I have a small little story about this on stress and fatigue. We used back in 1998, we were doing a study at the Alamogordo with the F-117s. And just as a sidebar, we had a special eye tracking device that was getting ready to be put on the market for factory workers, to where they could come in and they would put their eyes into this system, and it would measure pupil diameter, and then it would ask them to track these green lights that move across. And if the system determined that they were fatigued, then it would not allow them to process in to work that day. So again, this particular device was in its infancy. We were just testing it along with what we were doing. But this study we were doing was actually a fatigue study, and we did notice that as people got more fatigued, that they had difficulty with following the moving dots, and their pupil diameters changed. So in fact, that could save in a factory working experience. It could save somebody from losing, some fingers, an arm, having a major accident. So it's can be used in that form. And as far as cognitive engagement, your eye tracking will help with attentional resources, and it will provide feedback on task difficulty and mental workload. Again, that can go toward various different avenues, from using heads-up display to working to getting anything that you would have workload in. And then performance optimization can be designed to mitigate cognitive fatigue and enhance performance in high-demand tasks. Now, there was a case to where they used on the Swiss hockey team, to where they used a glasses eye tracker to allow the goalie. They were able to see where the goalie was looking at to track the puck coming to the goal and see how he was reading the skaters on the ice, which is very interesting because they were using that for optimal performance enhancing, to make this goalie a better goalie. In human factors is, I would say, is the parent of neuroergonomics. But we've used eye tracking in a lot of military applications, looking at studying visual perception, at flat panel displays, attentional biases, and the stimuli like information saturation. Think about the F-22 Raptor aircraft. The helmet's about $300,000, $400,000. They got so much information coming in now that they're seeing, and plus they're able to fly unmanned drones with that. So they got so much going on, and the eyes are moving on. It helps them, the people who design these newer technology pieces that are supposed to help, it allows them to be able to see, if they're getting fixated, if it's too much, where their focus is at, if they need to move something to a different place. So it allows them to focus on visual attention. And then, of course, that also goes to training and skill acquisition. As we optimize training programs, we can look at the gaze behaviors so we don't get gaze lock on a particular item. Like a lot of new pilots in rotary wing operations, they get fixated on looking at altitude all the time, where they should be scanning and looking at all the instruments across the board. And when they get fixated on gaze, that can cause a lot of issues when they're not paying attention to, the trees they're flying around or other aircraft. So it helps with developing these individuals to experts in their field. Then applied psychophysiology, psychophysiology correlates, you can integrate eye tracking with psychophysiological measures such as EEG or FNIRS to provide comprehensive understanding of cognitive and emotional responses during tasks. Motion recognition, it can also assist in recognizing emotional states through gaze patterns, contributing to effective computing and human research interaction research. And then clinical applications, you can look at eye tracking as utilized in clinical settings that says attentional deficits, cognitive impairments, and emotional processing, various neurological, psychological conditions. Now, under clinical applications, I kind of think of the old Connors CPT test for attention deficit, to where if you were using eye tracking, you can see where the individual's focusing in at. That's just one area I thought of about this technology that can be used. But then you can, also use it in different avenues for to see where individuals are focusing at and maybe have attentional deficits. Now, also in applied psychophysiology, we always coming back to the cognitive processes, but eye tracking can be leveraged to measure psychological responses, contributing to understanding cognitive processes. And then the engineering concept is looking with applying psychophysiology with neuroergonomics. And neuroergonomics, just for those who may not have heard me talk before, neuroergonomics is actually human factors, but with the application of psychophysiology. So that's why it's called neuroergonomics. You're applying psychophysiology measures into human factors research. So you're looking at brain performance in everyday settings, where it's from driving to flying to user interfaces on different types of computer systems, and it involves the user experience. Here is actually a photo of one of the Swiss goalies, and you can see here that he has an eye tracking system that's wearable. And what they did in this particular study, they outfitted him with this, and they tracked him during training to see where the puck was coming from, how he was reacting, and how he was reading the game, which made him a better overall goalie. Down here at the bottom is another example using a wearable system. It was in archery. You can see you have poor accuracy on this first one, but good precision. And then you have good accuracy here and good precision, and then poor accuracy and poor precision. And so in archery, if the person is looking, you can see where their eyes may be drifting to. And again, eye tracking can help with this in enhancing performance or optimal performance. And so in training and skill development, under skill assessment, eye tracking will assist in skill proficiency and identify areas of improvement. And so it will allow you to assist your client to develop targeted training interventions. And then the feedback mechanism within training and skill development will allow for real-time gaze feedback, because this data is being collected real time, and then you can take a look at it and then go up onto your next particular task to keep on getting feedback and make corrections. So eye tracking is very important in training and skill development. And then it as far as it also aids in gaze behaviors and allows the individual to transfer different strategies from novice to skill acquisition. So if you have somebody that's new at flying, that's focusing on altitude all the time, then you can reinforce the scan pattern that we use. And just from my background, we use a scan pattern in a rotary wing aircraft of a figure 8 that's laying on its side, and you're supposed to constantly scan in a figure 8 pattern without staying focused in one area, but a lot of new pilots who have less than 100 hours tend to always focus on a couple of different instruments, and without being aware of their focusing on situational awareness. And so tracking with the eyes and being able to focus in is crucial to their mission objective. Human computer interaction, there's usability testing, interface design, and so you're able to look at website, like I mentioned, website design's a big area, gaming's a big area. They track eyes, they look at marketing's uses a lot of eye tracking. They look at where you're looking at, how you're looking at a screen or how you're looking at, I read an article, they put people with eye tracking wearable devices in a supermarket, and they were looking at different products on the shelf to see how they were scanning and looking for it. So they would be able to put certain products at a higher level, so the people's eyes would go directly there. So it has its commercial uses as well. And these particular interfaces, again, it's not just limited to the computer or people like in the supermarket. They're also using it for gaming design. So where they're being able to give the individual that's gaming a more robust interface to what's going on. Because again, there's an issue, a limitation to where on the peripheral side of each of your peripheral vision, the eye tracker may not pick up everything that's on the peripheral side. Okay. And so again, they're trying to track to see where your main gaze point is going to be. Did I miss a page? Let me see if I missed a page. Okay, as far as performance enhancement strategies, again, attentional focus training to be able to work on individuals, to able to help them. Like I said, going back, I don't mean to be repetitive, is that the hockey is a great one to being a goalie. This could be used in football, American football, I should say. Put it on a quarterback. You can see how he's reading the field. This can be used in military and civilian applications as well. They actually use eye tracking in simulated surgery for med students. So it's a tool that can be used to be able to focus attention and then make corrective measures on the fly. And again, I talked about cognitive load, looking at complex tasks and mental strain. You can see how much information the person is taking in if they're fixated in one particular area. And then it's adaptive because the eye tracking can be dynamically adjusted to the specific task demand based on real time. So if we were, say each of you were wearing wearable eye tracking devices, we would be able to collect that information to see if you're looking at your screen or not, or if you're looking someplace else, just for a simple example. So, and then we would be able to correct that, and then in real time, and to get you to focus on the point that we were looking for. Now, as far as future directions and considerations, there's multimodal integration, which is integrating eye tracking with other physiological techniques to bring full comprehensive insights into full cognitive processes in human performance. And there is ongoing research that explores novel applications of eye tracking data in fields of education, healthcare, sports performance, and human-robot interaction. Now, one thing I did want to do, since getting through this, I wanted to share with you the Dr. Sherman's Foundation. I just wanted to share this. Dr. Sherman's Foundation has purchased a eye tracking device that will be on display and for play and out in Pasadena. And as if everybody can see, this is an actual eye tracking device. You can see it's not that big. This one will mount at the bottom of a monitor or on a laptop. And then once you adjust the angle for the calibration process, then you can run any software you want for the tracking. So say I'm going to run a MAT-B. A MAT-B is a multi-attribute task battery from NASA. It does tracking, fuel consumption. It's like you're in a cockpit, okay? So I can run the MAT-B and have this running separately, and I'm collecting eye data based upon the application I'm running, okay? So you could use this, again, for your particular study that you may have, that you may want to see eye tracking data on a particular application, a particular event, and then your data is being collected separately. So this is standalone. You don't have to use particular software on this. And at the end, it will give you hot points, gaze points, fixations, saccades. It will give you all the data for you to be able to look and be able to analyze the data based on eye tracking. Any questions? I know it's a fairly, it's not a new technology, but I would say for us at Saybrook, it is. This is the first one that we have, and I've had the privilege of using eye tracking devices in military aircraft, and again, we're looking at them for fixation points on particular instruments. So. But it has a wide range of application. I really thought preparing for this, it was really interesting to see about the Swiss hockey team. I thought that was a great use. I mean, when I saw that, that was just great. Thinking about being a hockey goalie, and since you teach hockey with your guys, think about having your goalie wearing a wearable eye tracking device, and you're able to come back and see how he's reading the puck play and the guy's coming down, then you would be able to train him to be a better goalie because everything's coming at him and he's having to, deflect, a one-timer, and, off the pipe and everything. So, I mean, it can be used for different things. It can be used in driving. It's a remarkable tool if you choose to use it. So that's my presentation. Like I said, it's just a basic overview. I do encourage you in Pasadena to come play with it and, check it out and to see how it will work for you for your particular research now or in the future.
Well, thank you, Nick. That was awesome. I would fail the test because I'm preparing for a dinner party while we're chatting away, and but I have to say that I was completely engaged, and it's a whole new modality for me. I have not. You can't hear me. Everyone else can hear me. Can you all hear me?
Yeah, I can hear you.
Okay. Sorry, I'm sorry, Nick. Can you hear me now?
Yes.
Okay. So I was just saying that I would fail the test because I am preparing for a dinner party. People will be showing up here in 5 minutes. But I was completely engaged. I really appreciate your presentation. It was very clear. It showed all the salient points. And I have never used eye tracking, and I think it's a really interesting modality. So I appreciate having had exposure to that. So I'll open it up to everyone else.
Well, thank you. It's a little rough around the edges on the presentation. I've been working on trying to get something together for Pasadena. So hopefully in Pasadena, it will be much more fluid.
I thought it was awesome. You did a great
I thought
job.
it was great.
Yeah.
Thank you.
Gabrielle, you're up.
Absolutely, Nick. There was nothing rough about that, my friend.
Thank you, Gabby.
It was fabulous. It was fabulous.
Thank you, Gabby.
Of course. You mentioned something about NASA technology that's being used as far as eye tracking, and that makes me think that they've been using it for a while. What are your thoughts on them using this for something like Artemis? As we move forward into the space program, we're looking at landing on Mars and landing on the moon, and I'm just focusing on the landings. There's so much else that can be used. What are your thoughts on where that can be taken as far as that technology?
Well, NASA in particular, not just for the Artemis project, and those for who don't know what the Artemis project is, that's our next manned mission to Mars, to the moon that we're getting ready for. However, NASA has used eye tracking in training. The MAP-B that I'm mentioned was developed by a guy named Comstock, and it's used for NASA for astronaut training, and they do use eye tracking on that because of the multiple eye fixations. They want to make sure that they're looking at what they're supposed to, and not to get I just said again for repeating, they don't want to get fixated or gaze points on particular areas because they have to be totally aware what's going on, because in space you're using, multiple axes, not just X, Y, but you got an X, Y, Z axes. And so they do train with eye tracking, and they do evaluate the astronauts, but to the amount, I do not know. That's through their human performance division out of Houston. So I would not know without doing some research on what their training regimen is, particularly with the eye tracking. But I do know they do use variations of eye tracking devices.
What I'm wondering is if that can be used real time on real missions, because the closer you are to low Earth orbit,
Mhm.
right, and the moon doesn't have that much delay. The less delay
Right.
that you have, the further away you are. I think Mars is about a 20-minute delay, so
Right.
real time would be more difficult. But if you're close, then I'm wondering if NASA can use this for
I would think
real-time support.
I would think they would be able to be able to transmit um, back to Earth. But even if they did not do that, even if they had a system on board, because it's real time, they would be able to see where their fixation points are. But if they're able to transmit back to control, then they would be able to let them know, be able to see if they're fatigued. They have they have their medical guy that's monitoring everything. So, why not add this as an additional duty for him to be able to look at fixation, especially when they're doing any type of docking procedures or landing procedures? That's a possibility, but I would have to check because that's kind of out of my purview right now to know exactly, what their configurations are, because a lot of that's still classified. So they may have something similar to that, because I know they were experimenting with wearable eye tracking devices a couple years ago.
One last question, then I'm gonna, turn it over to Andrea and Horace,
Mhm.
because they've been waiting so patiently. How massive are these? These are very lightweight, right?
Yes, this particular one right here is super lightweight, but the wearable ones are like a pair of glasses. So they're super lightweight, and with with us moving to newer technologies and newer composite materials, I think they're just going to get lighter, because beforehand, the one that I used for the F-117 project, now Alamogordo, was a box about this big, and it was heavy and clunky. This one that Dr. Sherman's Foundation got is super light, small. You can move it around. So, and the price point has come down on them to where they can be used common researchers can purchase them instead of, like big organizations, like NASA and DoD to be able to be used. So they are light, the price point's down, and the wearable ones are super light because they're wearing them during, like the Swiss hockey team, they're wearing them actually during training.
Awesome. Thank you, Nick.
You're welcome, Gabby.
I tell you what, Horace was next, and then Andrea. Before Horace, before you start, let me just modify one statement that Nick is making. It's not Dr. Sherman's foundation; it's the Behavioral Medicine Research and Training Foundation. And, Cynthia and Eric are on the board. We have several of our students and recent graduates on the board. So
My bad.
they support this program, but it's not me.
Yeah, my bad. I should say the foundation just
Not a
recently,
problem, Nick.
just
Not a
recently,
problem.
just
You-
recently purchased this, and they're giving me the opportunity to play with it before August. So I'm having a good time with it. So
I should point out, Rich is still alive, so we haven't named the foundation after him yet, so.
okay.
That day
Yeah,
will come, I'm sure.
thank you very much. Horace,
I think it was Andrea first, Rich, before me.
all right, Andrea, you're up. Andrea, you're muted.
Andrew.
Yes, can you hear now?
Yes.
Yes.
So my question is, if I have a tennis player and
Uh-huh.
let's say she's preparing to receive the server, so which equipment should be wearing? Like it would be the glasses?
Yes, it would be
Yes.
a wearable system, and they actually have used it for tennis players. So yes, they would wear the glasses, and you would collect the data and get the points, the gaze points, and then you would be able to go back and look at the data and make corrections for your athlete and be able to correct those. Yes, but it would be a wearable system.
And how the data is being processed? Like, can I be on my laptop on the stand and be watching what the athlete
Yes.
is
Yes.
seeing
Yeah.
at the real
Yes.
time?
Yes.
Okay.
Yes. And I do want to mention this: the wearable systems are a little bit more expensive than the stationary systems, of course. But the wearable systems, you'll be able to do that with your laptop and be monitoring everything that's going on. Yes.
And what is the transmission? Is like Bluetooth?
Yes, there's different type of systems out there that transmit, yes, in different
Okay.
ways.
And is the glasses waterproof, or I should use in sports only like baseball, tennis?
I'm not sure about waterproof. I don't know. I would have to get back with you on that, Andrea. I could check for you, but as far as waterproof, I do not know. I've only seen them used in like football, hockey, tennis, those types of things. But I can check for you. It would not surprise me if there was something out there like that. I would just have to check for you, but I'd be glad to check for you.
Okay, thank you.
Yeah, I'll send you an email this week and they'll let you know.
Okay.
Okay, Horace.
Nick, I can see one very important application for zoo and wildlife veterinarians, and that's in darting animals. In darting animals in the wild, one of my concern, and this is a concern also of my colleagues, we never really want to have the dart strike any of the nerves that can cause permanent paralysis or damage, because sometimes you would have to dart an elephant, for example, from a helicopter. And if the dart hits one of the major nerves and causes a permanent paralysis, that could be a big PR disaster. So I think that the device that we just got for the Behavioral Foundation, that would make a very interesting thesis project of studying, making sure not to hit particular anatomical sites
Mhm.
on animals when you're doctoring them. But I'm not going to change my dissertation topic. It's a it's a
But
very interesting dissertation topic.
yeah, but you're so right, Horace, because they're using eye tracking also with medical students, assimilated surgeries and procedures, just to make sure they're looking at where they're supposed to, selecting the particular area. So you know, you make a mistake in assimilation, whatnot, it's no big deal, because you're not working on a real live individual, but you're able to see where the person's looking at, to see if they're, nervous, jittery, getting around. So in your application, yes, making sure you avoiding nerve bundles and whatnot for darting animals would be a great application.
So everybody realizes this is biofeedback, right? You should have made that connection. This is a different type of biofeedback.
Feedback.
Feedback it is.
I
So
can't help
other
thinking about
questions?
what it would be like for a piano teacher to be able, when you're trying to read multiple notes at the same time and
Hmm.
sight reading, how interesting it would be to see, an experienced reader where they put their eyes versus a beginning student and how it works out. So
It's interesting you say that, Eric, because I saw a piece of literature talking about using the wearable glasses and about training musicians. But I didn't get too much into it just because this is just brief. Hopefully this will be more developed come past the time. But yes, looking at I'm not a musician, but I can just see looking at keys and going across about how the eyes are moving for musicians would be important, and how you could use that for feedback to able to assist them and to get more proficient.
I
I was actually thinking about that, Eric,
yeah.
in terms of conductors and music scores,
yeah.
because they're
Ah,
looking at how many rows at a time, and the difference in the piece of music is often not the orchestra, but the conductor.
yeah, and so when I can't read music, but I would assume by looking at multiple lines of music, with looking at their saccades going from one line of music to another line of music, how often are they getting ahead going from one to another, or do they know it so well that they're able to conduct that piece of line and where they're already have moved their eye focus over to the next line. So that would be very interesting to find out, because on some of those pieces, they're flying. They're flying.
It's the second
what I
one. They
wanted to
know those
say,
pieces
yeah.
backwards, forwards,
Yeah.
inside out, and can do it in
Okay.
their sleep by the time you conduct it. But
Right.
they're still moving around.
Right. So that would be another application for the wearable. There are a lot of applications for the wearable. Like I was mentioning before, in one of the pieces I saw was being actually in a supermarket, and they were looking how to put their higher price items marketing wise on the higher shelf, the lower price items on the lower shelf, the generics, and seeing how people move their eyes and see where the exact gaze points would be for marketing.
Gabrielle is up.
Awesome, thank you. Yeah, I just didn't want to talk over everybody because Eric, you and Allison had some really good points, and I love where you're going with this, Nick. But one of the things that I had wanted to mention is, having played piano, one of the things that I have done is memorized it, and to where I'm not even really, it would be interesting to see, but I'm not reading the music at that point when I get proficient enough. And I haven't played in a while, so don't hold me to this. But when I would practice and play, it would get to a point where I'm not reading that music note for note for note, because at that point in time, I've memorized enough of it to where I'm just using it for a reference only. And so I'm wondering about the limitations of some of the eye tracking software, or understanding some of the applications. I mean, because Allison, you were saying the same thing that I was thinking about memorization and knowing this back and forth when it comes to conducting. I mean, you still have to use your eyes when you're looking at the orchestra or the choral singers or whomever it may be. But it's not quite reading it note for note, and it's not like you're learning it. And so I'm wondering how that might affect looking at the eye tracking data.
Or when you're playing a piano, and forgive me, I don't play, but when you're playing a piano and say you do memorize it, do your eyes still track across the keys, looking at where you're going, hand placement, or?
Yeah, they will be tracking. It's just visually, I know for me, my visual sense isn't looking at it in quite the music in quite the same detail that I do when I'm learning a piece.
Right. But so when you're playing across, say you know the piece of music, are you still looking at the keys and tracking your eyes to say you're going to the left of the keys or the right of the keys?
Yes, the general motion is the same.
Right. So maybe the tracking, looking at saccadic velocities from one end to the other end, the rapid eye shifts from where you're going from one key to another key. If you're fixed up on a particular set of keys, a gaze point on a particular set, that's maybe your central home point. I don't know.
Most piano teachers won't let you look at the keys, Nick. You look at the music.
That's true.
Your hands are on the keys.
Okay.
And what I was thinking about it would be new music. If you're trying to learn music, you're seeing it for the first time. So many things you have to read and process at the same time, and that's amazing to me about piano players compared to those of us that play one note at a time. Our skate is one series of notes for the piano, and particularly for the conductor when you've got now multiple lines on it. That's a whole different visual thing. But yeah, once you've memorized it, you're just using the music as a little reference, but you don't really look at the fingers part of it.
Right. I could see where there could be an application there, just, once you get thought through on what your actual objective is, because I really do think wearable eye tracking is where the future's at. We'll be able to do that. Apple's even coming out with a new eye tracking glasses that's going to supposed to be out in 2026. 2027. So I don't know what their deal is going to be with their particular eye tracking glasses, but it's supposed to be for commercial everyday use. So,
Probably pay your bill by blinking your eyes.
Yeah.
Okay, other comments, questions?
That's another application, Eric, what you were saying for guitar, music teaching, any of that.
I also think just education, think about how they organize academic books. They don't make any sense. I had so much trouble even with the fundamentals of psychophysiology book, because there's graphs and pictures, and I lose my place on the page. But kids with ADD, ADHD, autism spectrum, I mean, if somebody who doesn't have a diagnosis has trouble getting through those books, what are they doing? That's all eye tracking.
Yeah, that's in education, looking at things like that, that's a great application for wearable eye tracking. And not even wearable, you could put that text on a computer screen and just see how people are tracking up on that on a fixed station if you didn't have access to wearable. But yeah, it's a great technology that can be used, I feel, within our department and combined with a lot of the other type of modalities that we use to be another tool to be able to drive each and every one of our particular research questions home, depending on what we do, if it's applicable to your particular research. So.
Lots of applications. This was awesome, Nick. Thank you.
Welcome, Gabby.
I'm going to turn off the recording now because I think that's a nice thing to put into our archives. It should be up on the YouTube, the psychophysiological YouTube channel so that if you want to come back and review any of this, it should be available along with the other ones.
And Andrea,